Hello everyone, my name is Ryan Schuell. Welcome to my channel. So today I want to talk about how to optimize scheduling assignments using Python. I have a couple of videos on my channel that cater to this type of topic. Hopefully there's no duplication. I tried not to do that. I tried specifically not to duplicate things because why would you do that, right? It doesn't make any sense. If you have one video that explains something, you don't need to duplicate, right? But I think this complements some of the other optimization workflows I have pretty well. So I'll just put this out there. And I think it's an interesting problem that we're trying to solve. And I think the solution is equally interesting as well. So why would we even try to do this? There's a bunch of reasons, right? To prevent worker burnout, to ensure safe staffing and optimal patient outcomes, to reduce labor costs, to honor employee preferences and improve retention, to make sure that scheduling is fair and equitable and non-biased, right? To ensure compliance with laws and union contracts if those exist where we're operating, to cover fluctuating demand, improve overall system efficiency, basically to provide better schedules and better outcomes for the patient and for the workers as well, right? So we're going to create a couple examples. We're going to assume 5 nurses, 7 days a week, and 3 shifts. So morning, afternoon, and overnight. The overnight is going to be de-emphasized. Okay, you'll see in just a moment. We really want to try to downplay the importance of overnight because number one, there's just not a huge demand unless there was a catastrophic accident or some kind of who knows what, conflagration, big fire, or something involving multiple car wreck, right? A horrible accident on the highway. Then you're going to have patients coming into the hospital. But aside from these events, which hopefully are somewhat unusual, unpredictable too, but hopefully to a lesser extent unusual, most of the time I think we'll have morning and afternoon staffing requirements, right? Not so much overnight, sometimes overnight, but that would be de-emphasized and hopefully de minimis. Hopefully we don't need that too much. So let me create a basic schedule over here in terms of demand. So morning, we're going to say two nurses are in demand, afternoon 2, and then overnight, just 1 nurse. Okay, that is the expectation. So 2 in the morning, 2 in the evening. This is early evening. Late morning goes into afternoon. Afternoon rides or overlaps into evening, and then overnight, right? This would probably be like the 11 to 7. Morning would be 7 to 3, I think, and then 3 to 11 would be the evening time, right? So that's the basic expectation over here. So we have the nurses, we have the schedule. Basically, we're going to use PuLP to help us solve this problem in an optimized fashion. So this is a great optimizer right here. There's a few in Python that I use on a pretty frequent basis, pretty regularly. Basically, PuLP for any kind of linear programming, SciPy optimized for nonlinear programming, and GarobiPy for things that are fairly complex, kind of next level after SciPy optimize. Certainly PuLP won't solve that. SciPy optimize might, but probably won't. GarobiPy is a nice solution. I believe you actually have to pay for that. I had a free version, which was kind of diluted, watered down a little bit, but I believe that there's some supercharged version that you actually pay for, but the benefits certainly outweigh the costs. It does some pretty amazing things that you just can't do with a normal optimizer. So we'll set up the problem right here. We are going to require coverage for each shift of every day. Again, morning, afternoon, or early evening. You can call it the same thing. And then overnight, that's the overnight shift. So for D and days, we're going to have 7 days a week. For S and shifts, there's 3 shifts. We are going to minimize the demand for nurses, right? So try to cut the demand down to the bare minimum, but we still have a certain minimum requirement that we need to fulfill. Okay, so number of nurses over here is 1 to 6. Number of days in range 1 to 7. I think it's really, what I have 1 to 8, 1 to 8. Oh, 0 to 7, 1 to 8. Okay, that's the same thing. That's 7 days. And we have morning, evening, and night. These are the shifts, all right? So this is what the schedule looks like, but it's all over the place. This is the non-optimized schedule. Let me do for D and days. For S and shifts, we're going to minimize the problem right here. For N in nurses, so number of nurses. So let me go back here. What do we have? We said nurses. We have 6 nurses. 7 days a week, right? Monday through Sunday, and we have 3 shifts, okay? So we have the nurses there. D and days, we're going to optimize this. So we're optimizing days and shifts, and nurses during the days. Okay, so the maximum number of shifts that any nurse can have is 5. Now you can change this to something else. 4, you would probably need more nurses. I don't know if you could satisfy all the constraints of this problem with 4 nurses working. I'm sorry, with 6 nurses working 4 days a week. I'm not sure if it would work with 6 nurses 6 days a week. We'd have to test a couple different scenarios to know for sure. I know when I set this up, 5 works fine. Okay. So again, we're trying to solve for this. For n nurses, we're going to minimize the number of nurses based on nurses, days, and then shifts. Okay. And then for n in nurses, so we have 6 nurses, right? For 1 through 6, we're going to loop through all of these items right here, right? For n in whatever this is, this could be list, this could be loop, right? We didn't name it loop, we named it nurses. So this one has to have a specific name. This can be anything. This can be it can be my name, it can be something, right? That's very vague. I don't think you want to name that. You want to have something that kind of makes sense, something that has a purpose, something that has some kind of relevancy or kind of describes and defines what you're trying to do for. So I think this makes sense for n in nurses. For index in range length of days. So the index is just the count of all the items in the range. Okay, so we go through all the days, count the items, and we're minimizing the number of nurses. Days, this is a night shift, and this is the morning shift. Okay, and let me go ahead and Control Enter to refresh that. Let me go back one. I think I missed this step over here. I missed this over here. I thought I did that one. Maybe not. You have to do this in order, right? So everything has to be set up and fed into memory. Otherwise, the sequence doesn't know what to calculate, right? You have to feed in all the variables to the problem and then do the minimization calculation. So if you miss a step, then you get these errors, right? But if you go over here, run, if you go into the last cell, run all above a selected cell, you click right here, it's going to run everything in a linear fashion, and you're good to go, right? So when I skip around like this once in a while, I miss a step, so I apologize for that. So that was it. I picked it up and we can move on. So the problem here is in a feasible range. We have enough nurses to satisfy 5 shifts, 7 days a week, and all the shifts are three per day, right? So morning, afternoon, and evening. So let's display all the rows in the schedule. So these are all possible combinations of nurses, day shift, or day of the week, and then shift. So this is evening, right? This is morning, evening, morning, night. So we have 1 at night. Again, the night is de-emphasized. We're not expecting too many incidents at night unless there's, again, some type of catastrophic accident. We're not expecting full staff, all hands on deck overnight. Morning, afternoon, yes. Night, no. So night is de-emphasized, right? And we're just printing out all the results that we get from above. So we have schedule rows over here. That comes from this list. We're going through the list, appending all possible combinations of nurse in nurses, day and days, and shift, and this is a dictionary. That's where we have the key and the value, and this is a key value pair. So we're taking the combination of nurses, days, and shifts, appending that into a list, and converting the list into a data frame. So in this one block of code, you can see the 3 primary data structures in Python. I use these ad nauseum all the time: list, dictionary, and data frame. Data frame is my personal favorite. I came from an Excel background. I did VBA programming for years and years, so I was used to the column and row format. So this totally makes sense to me. Honestly, when I got started, dictionaries and lists were kind of foreign. I had to figure that out, but gotta do what you gotta do, right? So here's all the days in the week, 1 through 7. Here's all the nurses. We have 5 nurses on schedule. Morning. This is morning, noon. So this is evening and morning, noon, morning. This is a night. This is a night schedule. So N is night, right? So this is morning, night. This is evening and morning. So night is overnight, presumably 11 to 7 a.m. Morning is probably 7 to 3, and 3 to 11 p.m. would be the night shift, okay? So that looks good. We take the results, pivot it. I'm going to show you what this looks like in just a minute. We're going to create a heat map, or an intensity heat map based on which nurses are working, which schedules, which day of the week. Okay, so if we go down here, we see the heat map. So this corresponds right here. N is night, and we have another N over here. So we have morning and night. So day 2, nurse 1 is night, and nurse 2, day 1 is night. Okay, so you can see this over here. So this is the night shift. The light yellow is night, and these darker purples are morning. So you can see shift 1, shift 1, shift 1, shift 1, shift 0, and this is shift 3, right? So 3 is overnight. This is 2, and these are 2. So orange is 2, blue is 0, yellow is 3, and what else we have here? 1 is purple, right? So you can take this and visualize it. This looks pretty nice right here. You can kind of tell what's going on when you plot that visually using Plotly over here. We have the heat map. The X is the day, the Y is the nurse, and the color is the shift. That's exactly what you see down here. So day is day of the week. That's the X-axis. The nurse 1 through 5 is Y-axis, and the color is the shift that the work is nursing. So it's all picked up from right here. Right. We have a dictionary, day, nurse, and shift. So these Plotly charts are great. I love it. I'm a huge fan of these. You can zoom in, you can zoom out. You can see all the details. Double click to zoom out. When you put the mouse over it, the bubble pops up and you see all the details. So again, I have a Plotly chart down here. Again, nurse on the X-axis, number of shifts on the Y-axis, so we're counting, and we're looking at the total shifts per nurse. This is a workload balance. So nurse 1 has 5 shifts, okay, number of shifts. Nurse 2 has, looks like 6 over here. Nurse 3 has 9. They have 9 shifts. Nurse 4 has 6, and nurse number 5 has 5. Okay, remember 5 nurses, 7 days a week, and the shifts can be 3 times a day, morning, evening, and overnight. So let's look at one more view over here. Nurse is going to be X-axis, just like we saw above. So nurse is horizontal. The count is vertical. You see us all the time. You can flip these. You can put the nurse on the Y-axis and the count on the Y if you want a horizontal bar chart. You don't see that too much. It's a little bit confusing. I think this is more intuitive, more natural, and in the real world, this is the application you see 9 times out of 10, right? So nurse number 1 is in blue. You can tell over here. Oh, wait, this is a shift. So the morning shift is in blue. If I click on this, you can turn it on and turn it off. So you can toggle it. That's kind of nice, right? You can toggle these. So the morning shift is blue. The noon is red, and the evening is, night is red, and evening is in green. So you have one shift over here at night. And this is nurse number 1. Overnight, you have nurse number 2 working night, and then nurse number 4 working night. And this nurse works morning to noon, and this one works morning and noon. Okay, so let's look at this, just a slightly different view. This is a group bar chart. So you have bar over here. We are setting the bar mode to group. Y is going to be the assignment, and X is going to be day. So over here you see nurses on the X-axis. Now you see day. Whenever you're plotting a time series, this is very common to see the day on the X-axis and the count, or the sum, or you can have any kind of metric, min, max, mean over here on the Y-axis. That's very common. So here you see number of nurses assigned. So for the evening shift, this is in blue. Remember, we have night shift, but that is de-emphasized. Day 1, day 2, and day 4 is the night shift. You see that over here. So shift 3, right, is in shift number shift N is night in red. This is night, and this is night. So we have 3 night shifts, and in green, the shift is night over here. So night is green, and again, you can toggle it on and off. Same with the red. And that same with the blue, and everything is grouped together by a day of the week and by assignment for the shift for the nurses on the Y-axis. So going vertical, going up and down. Now in this problem, we don't actually minimize the costs at all. All we're doing is assigning schedules to nurses. So all the nurses get all the hours that they need. They are assigned morning, noon, or overnight based on their skill set, based on what they need, based on what they want to do, right? We try to allocate the days sometimes to the nurses that want those. Maybe somebody has an overnight shift and that accommodates their personal life better, their personal schedule, whether they have kids or no kids or whatever. Maybe that's a better option for them. That's what we're trying to optimize. We're not trying to save money in this case. Most of these optimization problems I do, we're trying to minimize the cost, right? Or something like maximize utilization of some type of operations process or some equipment or some raw material. In this case, the optimization is just allocating the right work to the right people at the right time. We're not looking to save money. That's a different type of problem. So I don't care about the finances in this case. Most of these optimization problems, I have over 24 on my channel. I am trying to optimize the cost, minimize the cost, right? In this case, that's not it. I'm just allocating the right time to the right people at the right shift, right? For the right shift. So that's the problem we're trying to solve. And we just solved it. So there we go, guys. That's it. That's it. So I'm going to wrap it up here. Kind of a shorter one, not tons and tons of stuff going on, but I think I illustrated the point about how to do optimization, how to match the workers' needs in terms of the shift that they want and the shifts that are available. So everybody's happy, right? And we're not creating any bias or playing a favoritism or anything like that. Let the computer do the allocation and the optimization. That's the fairest way to do it. Okay, guys, so I'm going to wrap it up. I am going to save a copy of this code too, and I'm going to share that with you later. So you have every single block of code you need. Copy paste that into your own Jupyter notebook, run it, and you will get the exact outcome that you see here. You'll get exactly what I got, unless you change the inputs a little bit. And I would encourage you to do that, right? Just to see how these things work, see how they function. Go ahead and add. You can add the fourth shift here if you want to. I don't think it's necessary. We have 3 shifts, 8 hours, 8 and 3 is 24. It covers a whole 8-hour day, 7 days a week. That doesn't really change, okay? Whether you like it or not, that doesn't really change. You can add nurses, right? If you want to add 10 nurses and fewer hours, maybe every nurse doesn't work 8 hours. Maybe you can have fewer nurses and work more, maybe 10 hours, 12-hour shifts. That's common. I have a friend that's a doctor. He actually works, I think his schedule is just about to change. He's going to work 2 24-hour shifts back to back. So that sounds grueling, but he only has to work 2 days per week and he has 5 days off. So it's probably worth it. I don't know I don't know how that would work with my schedule, but I'd like to try it. I'd like to have a 5-day weekend. That sounds nice. So you can play around with the inputs, see what the outputs are, and yeah, let me know in the comments if you find something new, interesting, so discover some new technique or some new optimization method, share it with the community here. Please go ahead and subscribe. It helps my channel. I already saved the output here, I believe. Let me check downloads. Yeah, there it is. So I'm going to share the file when I share the video. I'll put that up later today, so keep an eye out for it. And I'll see you guys in the next one. Goodbye for now.